Hi, so in this video we're going to be talking about counting our way to probabilities. So to get started, there's a few things that we want to know before we hop into any of the problems. So the first is this exclamation mark symbol. When you see this in math, it means a factorial. So if you had 5 exclamation mark, it would be 5 times 4 times 3 times 2 times 1. It's basically this number times this number next to it times the number next to it, and so on, all the way down to 1. The special exception is the 0 factorial is equal to 1, but everything else is easy flying. The second concept, well, second and third, is the idea of permutations and combinations. Permutations are when the order of your sets matters. So like if you had a family of ducks that were lining up and the order of each of the baby ducks mattered, that's where the permutations comes in. But combinations, order doesn't matter. You don't really need to worry about how they're lined up. So the example I give for combinations is you are packing for a trip and you have 16 jeans and you need 4 jeans. You pick your 4 jeans and you throw them in the suitcase. It doesn't matter whether the red comes first or the blue shirt comes first. It doesn't matter whether your favorite jeans comes first or your least favorite jeans comes second. It all just mixes in the suitcase. It doesn't matter. But permutations is where that order does matter. With permutations, your number is always going to be bigger than it is with combinations. And the 2 formulas for these are, well, for permutations, it's going to be represented like this: N, P, R, and it is N factorial on the top, N minus R, in parentheses, factorial of that. And the N in both combinations and permutations stands for the number of items that you have, and R is the number of items that you choose. So if you had 12 pieces of pottery and you were only allowed to choose 7 of them, N would be 12 and R would be 7. The combinations formula is NCR is equal to factorial of N over R factorial times N minus R factorial. So we'll be using that. And let me just see if there's any other things I need to bring up. Okay, there's also permutations with repeated objects. So if you, for example, in this problem, it's telling us that Lucy was born on 08/05/1999. And we want to know how many 8-digit codes we can make with the digits in her birthday. However, we have some repeating numbers here. We have 3 repeating 9s and we have 2 repeating 0s. The formula for permutation with repeated objects is going to be N factorial over K, would be N factorial over our basically elements. And we'll get more into this when we address this problem. We also talked about the fundamental counting principle last video, but we'll review it here for people who missed that. It's basically saying if there's P ways to do one thing and Q ways to do another thing, that means there is P times Q possibilities of combinations. And we went over that with the examples of like a vacation where you can choose to go to 2 different places and there are 3 different hotel suites. That means there are 6 different options. So to hop into things, this one is telling us to evaluate the expression. And it has 8P4, which is our permutations, and it has 8C4. And basically, you could write this all out, and I think that's a good thing to do. You could plug in, we know that the n is going to be 8. The p is going to stay as p. We don't need to worry about that. And the r is going to be 4. So 8p4. However, some calculators have these functions inside of them. So I'm just going to use that. And after I plug that in, that gives me 24. So our answer would be 24. This is saying that there are 28 students in a high school senior class. And how many ways could the yearbook choose the winners of most athletic, class clown, and best school spirit? So this seems to be a equation where we want to use permutations, because it seems as though the order would matter, where you could have, say, let's say we have 4 students. One of them could be most athletic, one of them could be class clown, and one of them could be best school spirit. But we could also have someone else be most athletic, or like, if that makes sense. So our number of students is 28, and then it'd be P for permutations. And there are 3 options. So when we plug that in, we should get 19,656 different options. Now, if it was asking for combinations, which it's hard to tell with word problems like this, and I'm not even 100% positive that I was right in choosing permutation. It's really up to interpretation. The answer would be 3,276, and that would be 28C3. It's really up to interpretation. However, Hawks doesn't believe that. So it's, if you try one way and it's wrong, just try another way. Yeah. So this one is saying that the Jacksons are planning their next family night. They always have dinner out somewhere and then do something fun together. And there are 2 adults and 2 children in the family. Each family member is allowed 3 meal suggestions, and each child is allowed 2 activity suggestions. The family members don't choose the same things, and we're wondering how many different family night possibilities are there. So we have our 2 adults and our 2 children, and they each get 3 meal suggestions. We're going to be using the fundamental counting principle here. So 2 times 2 times 3 is equal to 12, and we know that each child is allowed 2 activity suggestions, so 2 times 2 is equal to 4. And then we want to do the same thing for this. So 12 times 4, and that will give us 48. This one is telling us that a mother duck lines up her 10 ducklings up behind her. In how many ways can the ducklings line up? So we know that if we have 10 ducks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have our mom duck. I don't know how to draw ducks. I'm sorry, I took more time than I needed to on drawing that. But we know that if one of the ducklings lines up, that duckling can't be there anymore. So there's 9 more possibilities for the second spot. So there's 10 possibilities for the first spot, but that leaves us with 9 possibilities for the second spot, and 8 for the third spot, and 7 for the fourth, and so on, which gives you 10 factorial. So our answer is going to be 10 factorial, which when you calculate it is 3,628,800. So there's quite a few possibilities there. And then for this one, it's saying Lucy was born on 08/05/1999. We sort of talked about this already, but now we can put it into motion because there were a few things that were probably a little bit confusing. So we have 8 different numbers. We have 08, we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 is going to be N. And, whoops, hold on. For the probability of this one, we know that 0 happens twice, 5 and 8 happen once, and then 9 happens 3 times, and 1 happens once. So what we can do with this is, so, sorry, I got distracted. So we know that there are 2 zeros, so we'll write that down, and we'll do 2 factorial times. We know that there's 1 5 and 1 8 and 3 9s. Whoops. And I think that, and then I don't remember if I said 1 5 or 1 8 or 1 1, but there should be 3 1 factorials on the bottom. And this top should be 8 factorial, and when we calculate that, that should give us 3,360. We're basically saying how many times it occurs, right, for each of our things. So our answer is 3,360. I know that's kind of probably a new foreign concept for you. If you have any questions, please let me know. Yeah, have a good one.